Hello and welcome to the video. Before we get started, if you'd like to provide input on future content and get our weekly newsletter, click on our survey. The link will be below. We also have a report on Ethereum 2, along with a bonus report on why you should learn Solidity now. Again, the link will be below. Now on to the video, and thank you. Okay, so today we're going to continue on with the Motoko, looking at the local objects, and we're going to discuss three things: the types, subtyping, and classes. So the first thing with types, if you look at types, one thing to be aware of, that in Motoko, objects that include a mutable state, changeable state, are not shareable. The way things are shared is you have an actor, and an actor executes remotely and only shares data that is allowed to be shared. So so we have our types of objects, and the first thing we're going to look at here is this counter object and compare it to this other one later down. The first thing is, notice this var count is 0, and it's just var count. Very important, because when you look at this one, it says nat8. So what's the difference? Well, nat8 puts a limitation. It's saying it can only be 8-bit numbers. Whereas the other one, remember we talked about natural numbers, it can go as big as it needs to be. However, these are considered the same type, the same class essentially. So what it says here, Okay, so today we're going to talk about the local classes and objects, continuing on with Motoko. The first thing to be aware of is, remember, they have a limitation in Motoko that you cannot share things that are include a mutable state. Mutable state, anything with mutable state can be in an actor class, and that's the way they get around it. They're shareable actor objects rather, but they're always executed remotely and only shareable data. Now, the other important thing is you have, this is illustrated by this counter object. This one, notice this count is 0. This is a natural number, and it can be as big as it needs to be. However, you have this version that has nat8. That means it can only be up to an 8-bit number. In terms of type checking, these are the same things. And so we're going to get a little bit more into that, but that's a very important distinction. As far as type checking concerned, they're the same, but in actuality, this one can overflow and the other one can't, because it's limited in terms of space for the size of the number. The next topic is subtyping. Now, subtyping is basically going from more general to more specific. A mammal is a more general class than a dog. And it's the same thing here. So you have this bump counter that has the method bump, And then you have this full counter that has ink, read, and write. And this is a good here. Bump, just bump, ink, read, and bump. And the least general, ink, read, bump, and write. Because bump, you can use any of these three. If you need ink, you can use these two, ink or read. If you want to write, you can only use this least general, this more specialized class. So that is the concept of subtyping in Motoko. Very simple. And one other thing to be aware of with subtyping is, and this is down here, it's done structurally. So in Motoko, it's not based on the names. You have two classes called different names, but if they are structurally the same, in other words, if they have the same methods and so on, then they are considered the same type in terms of type checking. So that's very interesting. And that goes back to what we talked about just above with the two different implementations of counter. So let's see. Classes, that is the final thing I want to discuss. So classes, you have objects, and let's see. Now I'm getting myself a little, okay. Let's go to classes. Classes are very similar to classes in any other language that you're familiar with. You see this counter class, and then you could call the methods on each of these classes that are defined. You can actually put this little object within a function and essentially have the same thing. So I thought that's kind of interesting. So this function actually returns an object. And now one other thing is, of course, they have constructors and pretty much behave the same way as you'd expect. Now it's not a separate method, it's actually passed into the class. And like in this case, you have counter, you can pass in a init. And this is one that has two different methods, an ink and a reset. Or you can have a buffer here. So init is a buffer of using this buffer library, and it's basically clones and clones the buffer, and when you add, you increment the buffers and you return the size, which is a nat. And reset, you can just reclone the buffer. Now, interestingly enough, you can guarantee that the buffer is of a certain type by adding this. So what this does, it's saying you define this type accumulated, and it's saying that the buffer has to be of accumulated. And since it does have the add, then it's fine. It'll work, because according to here, it says the annotation assures that the objects are compatible. It's saying that we're ensuring that this counter is compatible with this definition of accum. So here's another example of a class, bits, and next, and that returns a bool and has this method. So has this method next, and it's actually this of a structural type and a factory function. So type bits defines this, and again, let bits equal type bits. This gets, so you are, it looks like what you're doing is, yeah, this gets to, this is similar where you put a little object within the a structural synonym and a factory function, and they're both named bits. So this is one I'll have to look at a little bit closer. It's not, to me, well, because I'm used to classes and so on, this is a little bit more confusing. You're defining a type, and type is saying that you have this function that is going to return a bool, and so you define the function, and bits equals, it's similar to what they were doing up way, or was it? Let's see. They did, where they did this here, where they said you have a function that has the method increment that returns the net, and then this is within an object. So it's basically putting the method in the object and then defining the function return as a return of the method that's within the object. And this down here looks to be a similar type of thing. But again, if you're used to classes, I think this is a little bit more straightforward. Anyway, so what have we learned here? We've learned about the types and the fact that types are classified based on their structure, yet they could have differences, as we saw with the NAT versus NAT8 example. We talked about subclasses and specificity. So the more, if you have a class that has method A, it's more general than the class that has method A and B, and A and B is more general than the class that has A, B, and C. So that is your basic introduction to local objects and classes. And hopefully this has been useful and helpful. And thank you for watching, and I will speak to you next time. Take care.